Hi, good afternoon, everyone, or good morning, depending on what time zone you may be joining from. Welcome to our next series in password authentication or passwordless authentication. We have Chris Lee is going to be presenting again today. If you do have any questions, please go ahead and post them in the Q&A section. We'll go ahead and moderate those and make sure they get asked at the appropriate time. So for now, Chris, go ahead and take it away.
All right, thank you, Michael. So just to recap, this is the last session in our passwordless authentication series. We're going to be talking about Microsoft Authenticator and FIDO keys, but if you wanted to look at any of our previous sessions, we do have the recordings up on our website. So quick agenda, the title of the session kind of gives it away. We're going to look at software versus hardware passwordless authentication options. And then we're going to dive into the Authenticator and FIDO keys, but we're also going to talk about the theory about them and then also show you how to implement them into your environment so you can use them in a real world environment. So let's go ahead and get started. There's two types of security keys. There's hardware and software keys. A hardware key is something physical that is intended for pretty much one purpose only, your identity security. A software key is an app. Not that the app isn't running on some kind of hardware, but the interaction occurs through some type of software on the device for identity security. Now, you may be familiar with these types of keys as you've probably used them in the past for multi-factor authentication. But recall, multi-factor authentication is a combination of at least two of three things, right? Something that you know, something that you have, and something that you are. So these tokens provide you the something that you have on top of the username and password. So one thing we need to make clear early on, though, is that an MFA token is not the same as a security key. A hardware MFA token does not store anything, but rather just provides you some information like a rolling one-time passcode. The software MFA token may be a little more advanced in that it can provide like a one-time passcode or also prompt you for like a push notification. But the key here is that nothing credential-wise is stored in either of those keys that represents a credential, right? There might be some details that link the token to your account, but you can't just take that key and automatically authenticate as your identity. So which is better? Hardware or software token, as we start talking about how we use these for passwordless. And I guess I should have made the comment of security keys on the other hand for passwordless use a form of asymmetric encryption key pair. And we've talked about that in our previous sessions, but even though I just mentioned how hardware and software keys for MFA cannot be used for passwordless, we do have options in both of those spaces for passwordless. So which one's better? There really isn't a concrete case for one over the other. And the reality is that the best option that fits your business needs is going to be the best option to use for your organization, because that's going to be different for every organization out there. Let's start off with the Microsoft Authenticator app. The Authenticator app enables two security capabilities to extend identity authentication. There's the one-time passcodes and push notifications. The one-time passcode is based on an industry standard for what's called hash-based message authentication code, or Hmac for short. And that's the kind of the protocol for one-time passcodes. This uses an algorithm that takes two inputs to generate the passcode. There's a secret key and what is called a quote-unquote move-in factor, or a time interval. The secret key is something that's shared. This is established at when you register your MFA app with your account. It's just a shared key. That means both the app knows it and your identity service knows the key. It's the combination of that key and this move-in factor that the algorithm uses to generate the current passcode, which typically only lives either 30 or 60 seconds. This the time is based on pretty much the identity provider's capabilities, which in our case has been Azure AD. But if you're using a different identity provider, Google or Facebook or whatnot, their service may be different. It may be 30 or 60 seconds, but the Authenticator app can accommodate both. This pretty much makes the Authenticator app what's called a soft token for authentication, because this key is static and it's shared. It's not necessarily a strong form of authentication though, but it works well for multi-factor authentication. So therefore, a one-time passcode in the Authenticator app is not something that we consider as a strong authentication factor for passwordless. The alternative method is using a push notification, and this leverages the push services that are provided both by Google and Apple, as those are pretty much the main two mobile device platform providers. The notification itself is not a form of authentication, but it's used to initiate or trigger the passwordless sign-in experience. So both of these methods are really great when you come to MFA, but just remember that MFA is not the same as passwordless. So let's look at what we need to have to run the Authenticator app. What are the requirements for the Microsoft Authenticator app? So the primary requirement here is a relatively current version of either the iOS or Android operating system on your device. And because Android and Apple kind of rule their operating systems pretty well, the version of the operating system typically dictates the version of the device that's being used as well, because we can't run iOS 12 or later on a first generation iPhone. Same thing with Android 6.0. You can't use it on an older device that just doesn't support Android 6.0. So the first requirement is a supported OS version, which is iOS 12 and later, or Android 6 later. And that typically will mean that the device meets the necessary requirements as well. For iPhones, this starts with the iPhone 5S. And mostly because this was the first model that included what's called a dedicated security processor, or a secure enclave, that is a hardware-based chip that supports key-based authentication. For Android, the feature is known as Android Key Store, and it's actually been around since Android 4.0, but it wasn't until Android 6.0 that the requirements for the operating system required the hardware secure element component that does the security for the key-based authentication. So the last requirement here is the device must support whole device encryption using at least a PIN. And this is something that's been around for a very long time. So both Android and iOS do support this, and I'd actually be surprised if you found a device that doesn't support that. So before we can get the Authenticator set up as a passwordless authentication method, there's some prerequisite steps that we need to enable, and I'll go through that as part of the demo. But assuming all that is in place, what's the first step? We need to register the Authenticator app. So very similar to our previous discussions on like Windows Hello for Business, we have to register to be able to use a passwordless authentication method. So if you've already set up the app to be used for multi-factor authentication, that's great, but it's not the same setup as being registered for passwordless authentication. So to start, the user will go to their phones to enable their phone to sign in with the Authenticator app. It's a feature within the Microsoft Authenticator app itself. And the Authenticator is going to reach out to Azure AD, specifically the authentication service within Azure AD, to obtain an authentication token, pretty much that has the same claims as we've seen before in the Windows Hello for Business. It has a MFA claim, and it's validating the user identity. So if you did sit in on those previous sessions where we went through passwordless as a theory and then Windows Hello for Business, you might recall that a strong credential can only be provisioned when another strong credential is provided, and that's where MFA is coming into play here. You have to provide MFA to provision a passwordless credential. The authentication service is then going to reply to the device and say, hey, you need to register with Azure AD. Again, as part of the strong credential, the requirement is making sure that this credential, this passwordless credential, is going to be provisioned specifically to a unique device, right? The credential is tied to a single device. So the device is going to have to register. It's going to reach out to the device registration service to do that. This will create a device object in Azure AD so that it's known to Azure. But note that the device registration is not the same as device management. So don't think of this as enrolling your device with like Intune. Device registration is simply making it known to Azure AD. And that's required to be used for passwordless authentication. But you can only register a single mobile device. Specifically, you can only register a single instance of the Microsoft Authenticator app with only one passwordless authentication credential. Now, it doesn't mean that you can't have multiple accounts within that Authenticator app being used for MFA, but only one enterprise credential can be set up within the Authenticator app to be used with passwordless authentication. So once the device is registered, the authentication service will trigger an MFA request. Again, from our previous sessions, we know that it's required to have that strong credential to provision a strong credential. So require an MFA as a step up is how we're doing that when a username and password is provided. This will then cause the authentication service to then send a push notification to the device. And this is going to use the device platform specific service. So for iOS, it's the Apple Push Network. For Android, it's a combination of the Firebase Cloud Messaging and Google Play services provided by Apple or by Google. But that's how the push notification is going to be triggered to the device. Assuming the device has been enabled for a PIN or a gesture of some kind, like a facial recognition or a fingerprint scan, the authenticator is going to create a user key pair that's stored within the device itself, so that secure enclave on the device itself. So this is going to consist of a private and public key representing the user credential that's tied to the device. This means the key pair containing, that key pair contains some additional metadata that associates it to the device, right? Because again, the credential can only be used from the device it's being provisioned from. And then finally, the device is going to send back the user public key to the Azure Device Registration Service, and Azure is going to store that public key with the device object in Azure AD. This public key association with the device object is how the authentication service will validate the passwordless authentication credential. So note that the private key that was generated will never be shared or ever leave the device itself. It's only the public key. So this follows a very similar process that we've seen before as we walked through with Windows Hello for Business for device registration. It's pretty much, a little bit tweaks here and there, but it's pretty much the same thought process for the Authenticator app. So with that, I want to jump into a demo here. So the first thing we want to take a look at is enabling the service. And my toolbar has gone away, so I'm trying to find my browser that, here we go. For some reason my toolbar has disappeared. But anyways, the first thing we need to do to use the Authenticator app as a passwordless option is we have to enable it in our tenant. So we have to go to our Azure AD portal and then go to Azure Active Directory. And then we need to go to security and then authentication methods here on the left. And then we'll have an option for the Microsoft Authenticator. So here we have the option to enable the Authenticator. Now, you might be questioning, okay, I'm already using that Authenticator app as a for MFA. That's fine, that's great. Enabling this or not enabling this doesn't prevent you from using the Authenticator app for MFA. It only triggers or makes a difference when you're using it for passwordless authentication. So I'm going to slide this to enable to yes, but I also have the option down here then to scope this. If I wanted to only apply it to specific users or groups, I can do that. But in my case, I'm just going to do all users because I'm just in my demo environment. So there's really no reason for me not to apply it to all users. The next thing we need to do is over here, and it's not very clear because just because you hit enable, this kind of lights up. But we have to go to these three ellipses here at the very end of all users. And when you click that, we get an option for configure. So here is kind of the main ones that we want to make sure that we set correctly. We want to set our authentication mode to passwordless. And then these are two preview features that really make the process a lot more feature rich, I guess, or secure. The first is requiring number matching, and I'm going to show you what this looks like in a minute, but it's pretty much where the authentication service presents you with a number, and the Authenticator app gives you 3 numbers to choose from, and you have to pick the right one. The other option here is contextual information in the notification. So this is going to be information like a map, the GPS coordinates, the service that's requesting the authentication. It's not just going to be a little push pop-up that says, hey, tap approve or decline. It's going to give us some more details. So I'll click done there and save. So that's pretty much how we've set up. That's all you have to do to enable it in the Azure service. But let me pull up my phone here. I'm going to cast my phone, hopefully, to my screen. There we go. Okay. All right. So in my app here, from my previous example or my previous demos for Windows Hello for Business, we set up our test account here with MFA already. If I go ahead and tap on that account, you'll notice that I have this option here for, why am I not seeing it? Oh, yeah, right here in front of me, enable phone sign-in, right underneath the one-time passcode. Right now, I can use the app for MFA, but I cannot use it for passwordless. So I'm going to tap enable phone sign-in because this is that trigger that starts the process for device registration. And you can see here, what are the requirements? Well, my device has to be registered, but it's not. So I'll go ahead and hit continue here. And then it's going to ask me for my password for the account, if I can remember that correctly and type it in correctly on a small keyboard. Maybe not so easy for me. Okay, so I should get challenged for MFA. And because we enabled that contextual information in MFA, you can see here I'm getting I'm receiving a map that kind of points where I'm located. I'm in Akron, Ohio right now. And then it also tells me what app is trying to authenticate, and it's the Microsoft Authenticator app. So I can't see the number because the number is being displayed in the app itself. So I do have this link for I can't see the number. I can tap that and it's going to show me, hey, I need to tap number 27 or enter in number 27. So now I just type in 27 and hit yes. And that is validating that one, I'm multi-factor authentication, providing multi-factor authentication for my device, but also validating that that number matches what the service is expecting, so it knows this is the correct authentication attempt. So now it's going to try to register my device. I'll tap register. I might get prompted for MFA one more time here. Oh, looks like it's going through. And we're done. And that's it. So now when I open up the account, you can see here, passwordless is enabled at the very top, right underneath my name. I can disable my phone sign-in, which is pretty much removing the credential from the device, but my Authenticator app is now able to be used for multi-factor authentication. So before I actually go through the process of authenticating, let's go back and just look at the flow for what that looks like, all the stuff that actually happens behind the scenes, because there is quite a bit that does happen when you go to authenticate. So when a user tries to authenticate to any company resource, the authentication request is sent to Azure AD, which detects that the user has a strong credential registered for their account. See, I just registered my app, so it's going to notice that I have a strong credential available. The authentication service is then going to start the strong credential workflow for the Microsoft Authenticator app. And in our case, we have number matching enabled. So that's kind of what I'm depicting here. I've got 3 numbers, even though it's a little bit different what we saw in the demo just a minute ago, where I'm actually asked to type in the number. This might be a little bit outdated where they prompted for 3 numbers. But anyways, the authentication service is randomly going to generate numbers or a number to present. It's then going to use a push notification to send the devices, my app's platform, a push notification. And this notification is going to include a nonce value. If you recall from our previous discussions around passwordless, a nonce value is simply a randomly generated value that will be used to uniquely identify this specific authentication request. So if you need more background on a nonce, refer to our previous recorded sessions on passwordless because we go into that a little bit. But this should also contain the numbers that are required to authenticate. But again, what we just saw in my demo here, updates have been where we don't actually have to tap the number. We're going to type it in. So it knows what number to expect. The push notification in the app is going to prompt the user to type in that number, as we saw before. This acts as a proof of presence, but it also acts as another security measure to ensure that the authentication prompt is an expected and legitimate logon attempt. This should reduce any kind of muscle memory and just kind of blindly tap in, approve for any MFA prompts or authentication prompts. But if the user denies it or decides not to enter the information, this terminates the workflow, and then everything just ends, and then a new authentication attempt will have to be started. But assuming that I type in the right number, and I'm prompted to unlock, will then be prompted to unlock my credential using either a PIN or a biometric gesture that's been set up on my device. So I'm using my demo device here is an iPhone, so I have my Touch ID set up, so I can use that, or I can type in a PIN that I set up when I set up the Touch ID itself. The number match itself doesn't actually unlock the credential, but it simply enables the prompt to unlock the credential. And I know that might sound a little strange, but the number match is just simply, hey, this is the correct authentication attempt, and then it's going to prompt to unlock the credential using the biometric or the PIN. So the credential is essentially just a private key pair that was created when the app was registered. So the authenticator is going to use that private key, sign the nonce that it received, and then it's going to send that back up to the authentication services along with the typed in number. So again, the private key does not leave the device, but simply the nonce that's signed with it is sent back to the authentication service. The authentication service is going to verify the nonce using the signature on the nonce using the credential's public key that has been registered for the Authenticator app for the account. And then this response is also going to include some details about the authentication service to validate that the device is the same device that created the credential. So again, a passwordless credential is tied to a device, and it can only be used from the device in which it's provisioned. So if everything looks good, Azure AD is going to generate an authentication token and send it back to the client device. Now notice when I say client device, I'm talking about my computer up here, not my mobile app or my mobile device with the Authenticator app. It's my client device. So at that point, we're authenticated and we are good to go. So what does this look like when we actually do it in the real world? So let me, my toolbar is still missing, so let me pull up another browser session here. Okay, so I'm going to log in as my Leonard user. I'm going to go to portal.office.com. And actually, I'm not going to type in my account here. Oh, yes, I'm sorry. I do have to type in my account. Leonard@improvingdemos.com. Now, what you'll see here is I could type in my password and then provide MFA, but I also have a use an app instead. So let me make sure my phone hasn't fallen asleep, and let me get it back up and cast into my computer. Okay. Okay, so I've got my app open here. So now I can just say, hey, use an app instead. And what this should do is now I get a prompt on my Authenticator app. I don't have to have the app open. So, if I didn't have the app open, this just would have popped up on its own. But it's saying, hey, I'm trying to authenticate to the Office Home app, which is just the portal.office.com. I see the number in my browser, 54, so I'm going to type that in and tap yes. Then now I'm being prompted to unlock the passwordless credential. So typing in that number simply just said, hey, yes, this is the same authentication attempt, but now to unlock that private key, I have to provide my biometric or a PIN. And you can see now that I've sent that, or I've completed my Touch ID, I'm signed into my browser, and I'm able to access the portal. So that's how simple it is for the Authenticator app. Now, you might be wondering, well, hey, I had to go to the portal, I had to type in my username. Yes, it's not as convenient as maybe Windows Hello for Business and then using single sign-on, but think of it this way. The Authenticator app is really good to use when you have a shared compute environment, or maybe when you have your users going to endpoints that aren't managed and controlled by your organization. So like, for example, if I go to a hotel kiosk and I need to go sign into my Outlook via the web, I can follow the passwordless process here. And everything in this browser, I typed in my username, which is the same as my email address. But as far as any other information to authenticate, everything was done on my phone, right, through the Authenticator app itself. So no password was ever presented, no key or anything was ever presented from the browser. So there's really nothing that could be done on that machine. If there was a keystroke logger or anything like that, it wouldn't have been able to capture my password because I didn't use one. There's really nothing on that hotel kiosk that can be used to compromise my identity or my credential. But you know, whether or not you should be using a hotel kiosk for access is a different security discussion that we'll have another day. So that's
Hey, Chris, a question did come in about the licensing requirements for passwordless on the Authenticator. Can you go ahead and discuss what requirements there are from a licensing perspective?
Yeah, absolutely. So from a licensing perspective, there's technically not a requirement to use passwordless itself, but the catch is you have to be able to provide MFA for passwordless. And in specifically like the Windows Hello for Business example in our previous session, you have to use the Azure MFA for cloud trust or key trust. But because MFA is required, typically you have to have Azure AD P1, the Azure AD Premium 1 license. Now that's also included in like EMS or the M365 suites, but that's typically the minimum license requirement that you would encounter. And it's oddly enough, not because of the passwordless side, it's because of the MFA requirement to provision the passwordless side. So hopefully that answers the question. All right, so let's jump into FIDO security keys. The first thing you're going to notice about FIDO keys is that there are a lot of different manufacturers, and not all of them are listed here. I just grabbed a handful. But note that Microsoft is not a manufacturer listed here, as Microsoft doesn't actually make security keys or hardware keys. And mostly this is because there's plenty of other companies out there that do. So FIDO keys are a little bit different than the Authenticator app and Windows Hello for Business. So before we dive into the registration and authentication flows, there's a couple concepts that we have to review real quick. So first, if you're unfamiliar with what a FIDO key is, the main concept is that these are portable hardware-based authenticators that can pretty much accommodate several types of authentication across multiple interfaces. These hardware keys could have a one-time passcode, either displayed on the key itself or through some software interface. They can often also support smart card authentication, which is also known as personal identity verification or PIV. As this was kind of like an earlier form that kind of built into what is now passwordless and multi-factor authentication. But most importantly for us, they can be FIDO2 compliant, or must be FIDO2 compliant, to be used for our passwordless authentication scenarios. They most commonly connect via USB, as pretty much every computer device out there should have some type of USB. But there's also additional interfaces. They could be near field communications or NFC, or even Bluetooth. Low energy Bluetooth have become more popular so that you don't have to plug anything in. You just have to be in proximity of your whatever computer device that you're trying to log into. So Not every key can be used for passwordless. And Microsoft has established some specific criteria that each key has to meet to be used for their implementation of passwordless. So the main item here is that the key must support what is called Discoverable Credentials. It's otherwise known as a resident credential or a resident key. This simply means that the private key of the credential is stored within the physical device itself. If you did attend one of our previous sessions, or like I believe it was our first session, we talked about the WebAuthn and the CTAP2 protocols that make up FIDO. And you may recall that there's three main pieces to this. There's a relying party, which represents the authentication service or the identity provider like Azure AD, an authenticator, which is the FIDO key itself, and then the WebAuthn client, which is either the computer or the browser that's being used to authenticate onto. So in the context of a discoverable credential, this means the credential private key is stored on the authenticator and nowhere else, specifically not on the client itself, it's on the authenticator. Technically, the authenticator could just be a secure storage provider for credentials, but for it to be accepted by Microsoft, the secure credentials must also be protected by the authenticator itself. This is where a client PIN requirement comes into play, as it adds a second layer of protection to the credential. If the authenticator had some form of other interface, like a biometric sensor, like a fingerprint reader, the client PIN is not technically necessary, as the other interface could be used to unlock the credential on the security key. But even if you had something like that, most likely you're going to be prompted to set up a PIN, because that's always the kind of like the backup or the fallback method for when the biometric isn't available. Another feature that is, or another requirement, is called the Hmac Secret. This is a relatively new extension to the CTAP protocol, but it adds an additional step when the authenticator registers for a credential. At the surface level, this is simply an extension that enables the authenticator to be used for passwordless based authentication to a Windows computer in an offline manner, meaning the relying party like Azure AD isn't available to validate the credential, or it can't be contacted to verify the assertion from the authenticator. In this case, this feature enables the creation of a symmetric secret. So I want to make sure I point out a symmetric secret to be used to validate the assertion at the Windows client. To fully understand how this works, we might have to dive into more of a deep discussion on encryption methodologies, which we're not going to do today. But to try to make this as simple as possible, to describe it as simple as possible, when an asymmetric key pair is registered as a new credential to be used against Azure AD, so I register for my passwordless credential using my FIDO key, this extension causes the authenticator to also create a symmetric secret with the client that's being registered on. So this secret is generated based on two values: a key created and stored only on the authenticator, so the key itself, the FIDO key, and then a random salt value, which is generated and stored only at the client. Because both sides know the hashed value of that combination, when we combine those values and hash it, the client and authenticator can validate whether it's the same expected value, even though they only have, the authenticator only has the key, the client only has the salt, but they both know the hash. But that should let you use a FIDO key to authenticate against Windows, even when you can't talk to Azure AD. And then finally, there is a requirement for multi-credential support. And what this means is that the key must be able to support multiple registered credentials for a single relying party. So for example, if you had multiple accounts in Azure AD, such as a standard user account and an administrative account, both would have the same relying party ID as Azure AD, right? But to be compatible with Microsoft, the authenticator must be able to support having both of those credentials stored on the same key. And pretty much you have to be able to select which credential you want to provide. So I made a comment, or I used the term assertion here earlier on, and we didn't really dive into this too much when we talked about Windows Hello for Business or the Authenticator app. But these two concepts, assertion and attestation, become pretty important when we start looking at how FIDO keys work. So real quick, an assertion is pretty much what we've already talked about. I just haven't used that terminology as much. But an assertion is where we have a key pair, an asymmetric key pair generated that's been registered. So my key has the private key and the identity provider has the public key. I get a challenge from the identity provider, such as that nonce. I sign it with my private key. I send it back to the identity provider, who then uses my public key to validate that signature. And then it therefore validates that the key that I'm providing is a valid credential. So that is assertion. The part that comes into play a little bit more deeply here with FIDO keys is called attestation. So with the Windows Hello for Business, with the Authenticator app, we've been pretty easily able to identify the device that we're using. But with FIDO keys, it's a little bit different. So assertion and attestation, both of these happen for all passwordless, even though, as I mentioned, Windows Hello for Business and the Authenticator app flows, they do use it, but they're not as important when we are using FIDO keys. So FIDO keys have many manufacturers. Remember that slide I had with all the different brands on top? So there's many different manufacturers, but that also means that there's many different key types, and not all keys are equal. Attestation is how we validate the authenticity of the FIDO key, as well as whether it is trusted for use in our specific authentication case. So each FIDO key has an attestation key pair that is burned into it at the time of manufacturing. It's built in. This key pair is not necessarily unique, though, to the individual authenticator, but rather it's unique to the authenticator make and model. That's kind of a big point to make out there, is the attestation key pair is not unique to each authenticator. My FIDO2 key does not have a unique attestation key pair on it. It has the same key pair that is used across every key that is of the same make and model of mine. So, for example, this means like every YubiKey or YubiKey 5C NFC key has the same attestation key pair. So does like the Fission K33, or even for our authenticator, technically, the Samsung Galaxy S8 would have, every Samsung Galaxy S8 would have the same attestation key pair. The main point here is that the attestation key is not unique to the specific key that I have. And this is intentional per the FIDO requirements. If each device had a unique attestation key, then each credential can be tracked back to that specific authenticator based on its signature. The FIDO Alliance requires strict protections of user privacy. So therefore, by having all of the authenticators of the same make and model sharing the same attestation key, the user privacy is maintained, because I can never trace my credential back to a specific piece of hardware. It could be any one key out of the same line, right? So attestation occurs at the time of credential registration, which means it happens when we are creating or provisioning a new credential. So in our example, let's assume that the credential service is Azure AD. Therefore, we are registering for a new key pair credential on our FIDO2 key authenticator. As described in previous registration flows, when the user credential key pair is created, the credentials key is signed by the authenticator's private key. In this case, the authenticator's private key is the attestation private key. The authenticator also generates a package called the Authenticator Data. Very creative there in the naming, but it's called the Authenticator Data, which includes some additional details about the authenticator. But most importantly, it includes the Authenticator Attestation Globally Unique ID, or AA-GUID. This AA-GUID is unique to the authenticator's make and models. That's what sets it apart. The next step is that in the registration process is that the registration sends the newly created credential public key that is signed to Azure AD. The AA-GUID is also sent to Azure AD as part of the authentication data. And then because Azure AD uses the AA-GUID, or it has the AA-GUID, it can then look up specific metadata records hosted by the FIDO Metadata Service, or MDS. This is a service hosted by FIDO, and it acts as kind of like a third-party trusted information provider, right? So there are two key pieces of information that are stored in this metadata. First is the attestation, I'm going to struggle with that word, attestation trusted root certificate. The attestation key pair is pretty much backed by X509 certificates, so therefore it has a root chain to verify the trust. This is where the FIDO certification is important because now FIDO will validate it has that root certificate registered. The second piece of information is the details about the authenticator itself, such as how it guarantees encryption security, does it have biometric capabilities, or other features on the authenticator. But it's really that metadata that's hosted by FIDO that tells Azure AD, hey, does this key live up to the requirements for being used for passwordless authentication? The query response is packaged into a metadata record and sent back to Azure AD. When Azure AD receives the record, it extracts the trusted root cert, and then it uses it to validate the signature of the user credentials public key to make sure it was signed by a trusted authenticator. It will then also use the device metadata to register details about the authenticator so that when the credential is used, Azure AD knows what type of challenges or capabilities are available during that authentication process. So that's attestation. This is how a FIDO key proves itself to an authentication service, but there is also a concept of self-attestation to where authenticators use a self-signed certificate instead. In that scenario, it doesn't follow the exact same steps that we went through, but in that scenario, then we run into challenges of being able to validate, does that self-signed or self-attestation for a key actually say the key can live up to the requirements of Microsoft? So we'll see that a little bit here. But first, let's jump into demo again. Before we can use the security keys in our environment for authentication, we have to do some prep work, right? We can't just flip a switch and everything is up and running. So the first thing we need to do is, let me get back to my Azure AD portal. There we go. First thing we need to do is check something in Azure AD. So where I want to go is the Azure AD portal, and I'm going to look down here at, where am I looking up? User settings right here. And then at the very bottom, there's a link for manage user feature settings. In here, we have the option to enable what's called the combined security registration experience. Now for new tenants, this is going to be on by default. If your tenant is more than a year and a half, 2 years old, this may not be on by default. You might have to come in here and actually turn it on. But the important part about this is that it enables the combined registration process for security information, which passwordless FIDO 2 key registration is only available in that combined portal experience. So if you didn't have this turned on, you'd have the MFA portal for registering MFA, you'd have the self-service password reset portal for registering self-service password reset information. We need the combined registration portal activated for FIDO key registration. The second thing we need to do is go back to the main Azure AD properties here and go to security. And we're going back to the authentication methods. So just like we did for the Authenticator app, we need to turn this on for FIDO 2 keys. Now we have a tab here, unlike the little 3 ellipses that we had in the Authenticator app, we actually have a tab here that has some additional options for us. And these are important because they give us options on how we want to use FIDO 2 keys in our environment. The first option is allow self-service setup. And I would recommend this be set to yes, but this option enables users to set up their own FIDO 2 keys. Otherwise, you would have to manually provision out all those keys from an administrative perspective, or as an admin, I'd have to create all the keys myself and then hand those keys out to the users that would be using them. But in leaving this set to yes gives them the option to register their own keys. The second option here is enforce attestation. Now this one should be set to yes, but if you did need to use self-attestation keys for some reason, you could turn this off. But that could result in some undesirable experiences, because remember, using attestation, at least published attestation with the FIDO Alliance, makes it available, that information about the key available to ensure that it meets all the requirements to be used for Microsoft with Passwordless. Then the last item here I'm not going to turn on, but it's enforced key restrictions. So this is where you can block or allow specific authenticator key types. So if I wanted to only allow the use of the phishing K33 Bluetooth enabled fingerprint scan-in key, I could do that so that you have to use that one key. Or maybe that's one key I don't want used at all. So I can put the AA GUID in the list of either block or allow, and that controls what keys can be used. So that's it. I'm going to click Save here. That's pretty much all we have to do from the Azure AD side to enable security key registration. So very simple, just like the Authenticator app. Check the time. I am running a lot further behind than I wanted to be. So let me jump back here. I am going to skip over the registration. I'm just going to kind of click through here really fast, but it's very similar to what we've seen before, where the key is going to, the identity provider is going to request or send a non-spec to have the security key pretty much sign it, send it back to the identity provider, validates that the signed nonce is the same, and then we have a credential. So I hate to blow through that really quick, but given the time, I want to make sure we go through the demo of setting up and using the keys, because there's a couple more steps that we want to go through. So let's jump into the registration. Second to pull it up. All right, where's my VM environment? All right, so I'm using the same environment that I had for my Windows Hello for Business. So domain controller, Directory Connect server, and a Windows 10 client. So I'm going to log into my domain controller here real quick, and I'm going to create a new user. And I am going to create, let's go with Harry Potter this time. I'm a Big Bang Theory fan, but this time I'll use Harry Potter. And the reason I'm creating a new user, if I can type right, is because I want to show how we set this up for a brand new user who hasn't been set up for anything else. So my Leonard user has been used for Windows Hello for Business. I don't want to confuse that, hey, there's something in Windows Hello for Business that is a requirement or an impact to how we use FIDO2 keys. It's completely separate. So I've created my user. I'm going to jump over to my Directory Connect server, and I'm just going to initiate a sync. Delta sync, so that it sends up that new user account, and hopefully we'll be able to use it. So in the meantime, then we come back here to my browser. So this is Leonard logged in. I'm going to log out of Leonard. I'll close that so I can actually start up a brand new browser. Go. Roll.office.com. I don't know why my browser does this sometimes. It knows how to get there, it just doesn't want to get there. One more time. Fantastic. All right, not sure why that took a couple tries, but let's type in Harry at improvingdemos.com. All right, did I not type the password in right? Let me just reset this real quick. Just to make sure, it should have detected a password change. Whoops, don't want to go there. Should have detected the password change, so I shouldn't have to do that. Oh, sorry, trying to get back to my browser. Jumping between screens isn't the easiest here. Oh, come on. Harry at improvingdemos.com. Well, this is not good. Just checking the account real quick. It looks like it's there. I've got Harry there. All right. So let's just validate in Azure AD that the user is showing up. All right, I've got Harry there. So let's try this one more time. Harry at improvementdemos.com. Oh, fantastic. Of course, when we're strapped for time, it's when it's not going to work. All right, there we go. So logging into my new user that I just created, Harry at improvementdemos.com. I'm going to come up here to my profile and go view account. Get my phone started up here. The first thing when I go to security info is this is a brand new account, so it does not have MFA set up. Now remember, to register a FIDO key, we're going to have MFA. So I'm going to set up my Authenticator app so that I have Harry now registered for MFA. I will scan that with my phone. I'm not sharing my phone because I'm just doing this for the MFA part. Okay, so now I've got my phone set up. Because we enabled the security or the FIDO2 security keys at the tenant level, now I should have the option when I come in here, add sign-in method, I have security. If I didn't enable FIDO2 keys, I would only have the Authenticator app and phone showing. I'm going to select a security key, and it's pretty much going to say, hey, you're going to have to sign in with two-factor authentication. So here I am being prompted for two-factor authentication, even though I just MFA'd, but we need to make sure that this is a strong credential to provision another strong credential. So my key is a USB device, even though it's also NFC. I've got it plugged in, so I will select this a USB key. And then pretty much I'm just going to be prompted here saying, hey, we're going to redirect you to Windows to set up the process. If you haven't set up a PIN, you'll have to set up a PIN if it's a new key or whatnot. So my browser's saying, hey, what is this? Is it an Android phone or is it a security key? I'm going to say it's a security key, and now Windows is taken over. It's going to tell me I'm registering for Harry at improvementdemos.com. Now it's going to ask me to touch it because it has a touch sensor proof of presence, but this is the first credential I'm setting up on this key. So I have to create a PIN. Oh, geez. So now I'm creating a PIN on my key. It's going to ask me to touch it again to verify my presence. And now my key is set up for authentication. Now it's going to ask me for a name. This is a YubiKey. I'll just name it YubiKey. And I misspelled that, but that's fine. And now I have that key set up in my environment or in my account. I am not going to jump back to the presentation to go over how the authentication works. I'm just going to jump into what we need to do to configure or use it. So even though we enable that on the Azure AD side, I'm in a hybrid environment. So I'm going to want to be able to authenticate to my on-premises Active Directory as well. So to do that, we have to make a small change to Active Directory. And here I'm going to open up PowerShell as an administrator because I'm going to have to install a specific module. And this is going to be install module. The name is, and this is a long string, Azure AD Hybrid Authentication Management. Make sure hopefully I spelled that right. And I'm going to add the allow clobber. So you might get an error when you run this because ps-get might be outdated and you might have to update it to require or force it to use TLS 1.2. But I also include the allow clobber switch here because if you notice, if you look closely when it has the progress bar showing up at the top, you're going to see it install the Azure AD preview module as well. If you already have the Azure AD module installed, the allow clobber switch pretty much allows you to have them run essentially side by side. So the next thing I need to do is use this module to create a server object in Azure AD that is going to be our key authentication reference. So there's a couple of commands here. I'm going to create some variables. Domain is going to be improvingdemos.com. I'm going to create a UPN equal to my cloud admin account. So admin at improvingdemos.com. Then I'm going to create a domain credential object, and that is going to be to my on-premises Active Directory administrator account. So I'll get prompted for a credential. Hopefully I typed everything in correctly there. So I've got some variables set. Now I need to run a specific command, and this is a set Azure AD Kerberos server with the domain. This might take a second. Come on. Here we go. /domain, and pass it my domain variable. My user principal name is my UPN. That's my cloud account, remember? And then domain credential is my domain cred. Now you might wonder why I created variables, and that's a good question. For some reason, it doesn't like it when you type those in as strings. So those values as strings. So that's why I created them as variables first. But now I'm being prompted to log in. You would think that this would pull the UPN that I provided, but this is my cloud account, my cloud admin account. So it's authenticating against, oh, come on. There we go. It's authenticating against Azure AD to create this object, but when this is set, what you'll notice in the domain controllers OU, you'll see this new computer object for Azure AD Kerberos authentication. And that's really for the key-based authentication. The next thing we're going to do is I'm going to jump over to my Windows 10 device here, make sure I'm logged in with my administrator account. Okay. There is a administrative templates we have to install into Active Directory, because Active Directory, even if you run in 2016, which is the minimum requirement for key-based authentication, even if you're running Active Directory 2016 or even 2019, like I am in my demo, it doesn't have the necessary group policy templates. So I've downloaded this installer. You can get it at akams/admx/Windows 10-21H2. And that's pretty much the version number, Windows 10, 2021 H2 update. But I'm going to go ahead and just click the defaults here. And this is just extracting a bunch of policy files. While it does that, I'm going to open up my File Explorer, and I'm going to go to my sysvol. And in here, I'll go to my domain and then policies. And then I'm going to create a new folder in here called policy definitions. If you're not familiar with it, this is pretty much the central store for group policy. Pretty much enables you to update group policy objects. So I'm going to open that up. Because I'm on a Windows 10 device, I want to pull in the Windows 10 templates that are available within the build of Windows 10 that I have. So if I go to C, Windows or your system directory, and down to policy definitions, these are all the policy definitions that are available within Windows 10, at least the version that I'm running. So I'm going to go ahead and copy those over to my sysvol policies folder. And then I'm also going to come in here to program files, Microsoft Group Policy, and then here's that update that we just extracted in policy definitions. And you'll see we have a lot of other policy definitions. But what I'm going to do is I don't need all these languages. So I'm going to delete everything except English US because that's all I'm working with right now. But I will select all here and copy, and I'm going to paste, and then we're going to have to overwrite some files. So this way I'm getting all of the original Windows 10 ADMX files, then I'm getting all the updated versions of available files. So if there are some files that weren't there originally or are not included in the update, I'll at least have them from my base Windows 10. So by doing that, what I've effectively done is given myself the ability, now you might have to wait on AD replication, I don't since I'm a single domain controller, the ability to create a new policy that I'm going to call Fido Windows Login. And when I edit this policy, make this a little bit larger so we can see everything. Underneath policies, administrative templates, and then under system and logon, I'm going to filter or sort this by alphabetical. There's a policy set in here that was not available unless you did that updated policy templates, and that is turn on security key sign-in. And I'm simply just going to say turn it on, and that's it. That is applied to my Azure AD Sync OU, which has my Harry Potter user, but more specifically, my Windows 10 device that isn't that OU, because the group policy does apply a computer configuration setting. So I'll go back to my Windows 10 device. I'm just going to do a quick GP update to make sure it pulls that new setting. And then I'm going to log in with my Harry Potter account. But before I do that, because this is a virtual environment, I have to connect my, my key to the Windows 10 device. So that's just, I'm using VMware Workstation, and now you can see down at the bottom, my Yubico key is now connected to this VM. So I'm going to log off. Now remember, I've never logged into this computer with the Harry Potter account because it didn't exist beforehand. So I'm going to select Other User. And now that the computer has received a new policy, I can click on Sign In Options. I don't have to type a username or password, but I have this option for a key. So I'll tap the key or click the key. It's going to say touch my FIDO key, proof of presence, remember? And then I need to unlock that credential using my PIN. And then touch it again for proof of presence. And now I am logging in. It's pulled my Harry Potter account. I am logging into Active Directory. And then it will also authenticate me using single sign-on to Azure AD as well. So now I've been able to log into this Windows 10 device as a passwordless user. That is the first time I've ever logged into that Windows 10 computer. So I know I am past time here. Let's see. Jump down to, whoops. Well, so that pretty much wraps it up. I'm going to try to get all the way through my authentication slides here. Here we go. That wraps it up for our passwordless authentication series, authenticating with Microsoft Authenticator App and FIDO. We do have our upcoming series for identity and device access that is going to start on June 1st, and that will be every Wednesday, or it'll be on Wednesdays, starting at 12 p.m. Eastern Standard. That will be the first, first, third, and fifth Wednesday in June, I believe. So with that, I do appreciate everyone's time. I know I am over, but let's go back and see if there have been any questions. Michael or Rick, if you guys are still on, any questions that came in?
Just one additional one that you hadn't answered already, and that was pertaining to the Authenticator app, and if a third-party Authenticator app can be used in place of the Microsoft app.
So that's a good question. And to my knowledge, the answer is no. And it simply comes down to this. With the Microsoft Authenticator app, you have to register that app as a device. And the Microsoft Authenticator app knows how to register. Now, it's not device registration in that you can't just register your device and then enable another Authenticator app in addition to the Microsoft Authenticator and then use that third-party app for passwordless. It's because that device registration is also used then by the Microsoft Authenticator app to pull the device key pair to validate the device's identity when you're provisioning a user key pair. So it is important that you use the Microsoft Authenticator app. Now that might change in the future, but to my knowledge, that's why you have to use the Microsoft Authenticator app today.
All right, another one just came in, and that is, does Passwordless work for RDP logons?
Unfortunately, the answer is depends. I guess maybe the short answer is more of a no, in that you cannot use, so the Authenticator app is only used for browser-based authentication. It doesn't log into your computer, at least not yet. You could use Windows Hello for Business, but that is authenticating your local device, right? The computer that I'm using right now, I'd use Windows Hello for Business to log into. That doesn't do any kind of a single sign-on or pass-through to an RDP session, and RDP session cannot take advantage of Windows Hello for Business. So in that case, you could provision out additional certificate user certs for authentication in addition to the passwordless Windows Hello credential into the TPM. And then that way, when you do RDP sessions, you can use that certificate then for authentication instead of a username and password. As far as the Fido keys, not really, because again, the Fido key is plugged into your device that you're sitting in front of. If you're RDP into a server or some system in Azure, that Fido key is not plugged into that device, so it can't be used to passwordlessly sign into a remote system. So the workaround is more on the lines of certificates, but also how it could also come into play on how you access those remote desktops too, right? You know, web-based access, especially with like Windows 365. There might be some new capabilities coming into play with Windows 365 especially, but Azure Virtual Desktop or even published remote desktops through like a remote desktop gateway, to where if you're accessing it over HTTPS and it's a web browser-based session, you might have options there, but you know, for the most part, RDP logons really can't take advantage of full passwordless yet. Okay. Well, if there aren't any other questions, I appreciate everyone's time hanging along with us through a little bit over our time allotment. But again, we will post this recording up to our website, our improving website. So if you missed any of our passwordless authentication series webinars, you can go back and review those if you'd like, and also see all of the other past improving CSP webinars that we've put on, covering a whole range of other topics out there. So again, I appreciate everyone's time, and have a good rest of the day.